Hey, and welcome back to day 7 of the Advent of Code, test-driven development with phpspec. Today's puzzle is called Some Assembly Required, and we've got little Bobby Tables has been given a bunch of wires and bitwise logic gates that he has to assemble, and so we're going to help him because he's a little bit young. So we've got a bunch of wires that have an identifier, which the identifiers are all lowercase letters, and each of the wires carries a 16-bit unsigned signal, so a number between 0 and 65,535, and the signal is provided by either a gate or another wire, or it's provided at a specific value. It can only get a signal from one source, but it can provide its signal to multiple places, just like real wires. And so we're going to get a bunch of instructions that look kind of like this. So we'll have like this instruction would mean that the value 123 is sent into wire X. And if we do something like X and Y, it means we're using a logical AND between X and Y and passing that value on to the Z wire. We can also do left shifts, right shifts, knots, and that sort of thing. And so what we're going to do is emulate this circuit by running through the instructions and finding the answer. So the answer that we ultimately want to figure out is what is the signal provided to wire A. And if we look in our input here, we've got a whole lot of wire up instructions. And somewhere in here is wire A, and its signal is going to be provided from a series of other gates and signals and everything else. So we need to figure out a way to emulate this so that we can kind of work our way backwards and find what A is. So for me, this is one of this puzzle out of all of them so far, I think, is one of my favorites. It was a lot of fun to do, and let's go ahead and build it. So I think what we need to do is go ahead and build a circuit simulator, and we'll add functionality little by little until we've got a fully working circuit. So let's go back into PHP Storm. Here's my input file I've already saved in here. Let's get rid of that, and we'll say, all right, let's describe our circuit. So day 7 circuit. Oh, I need to describe it. I keep doing that. Alright, and now let's run it. phpspec run, and I just care about running day 7 stuff. And it'll build the circuit for us. So let's open up our spec in day 7. And let's open up our source in day 7. So there's our circuit. So first of all, I think I want to have my circuit be able to load this fact into itself. So or all of these facts, line by line. Each of these is a little fact. So let's do that. Let's do a spec, add public, because that's how I do. All right, it can add I don't know, a group or a fact. All right, and we'll do. Let's start off with a really simple one. Let's say it can add literal value group. Right. So we'll say, all right, if we've got this add group, and we'll add say 123 to A or something, right? So that says we want 123, the voltage or the value rather of 123 to go into wire A, and then let's figure out a way that we can get back that value. So we'll do this resolve A should be 123, right? All right, let's run that. And we created the add group and the resolve, so now we've got our circuit, we've got our add group, which is group, and our resolve, which is wire. All right, and this is going to be more complicated here, but first we need to add our group. So let's have we need to blow it out into parts, right? So in all of our input we have something on the left here of this arrow, and then something on the right of this arrow, and the something on the right is the wire. So each symbol, according to the specs, or according to the description, each symbol on the right is only going to appear at most once on the right. It can appear on the left multiple times because it can provide its value, but it can only get its value from one place, right? So we're only ever going to see GT here on the right. So if we store those in arrays, then I think we've probably got a pretty good reason to use the right part for the key in our array and the left part for the values. So we're going to switch them around a little bit. So in our circuit here, we've got our group, and if I want to split that, in my first example, let's copy this out. And just fair warning here, this may be a little bit longer one to do. So that's what I'm looking at here, just to start with. And we're gonna explode. So we'll do parts equals explode, and we'll explode on the arrow symbol, and we'll explode the group. And then we'll say parts 0. So the first bit is equal to trim parts 0, because I don't want to leave any of those spaces or new lines or whatever other junk. And we'll do trim parts 1. Alright, and then we're going to have a table of symbols, right? So we'll do this symbols, and the key again is going to be parts 1, and the value is going to be parts 0. Okay, and we need to make that as an actual thing, so we'll add the field. There we go. We've got our field of our symbols in here. So, and let's go ahead and initialize that as that. All right. So we've got a wire now. If we run this, let's see. It doesn't pass anything else. We're still failing because we haven't resolved, and that was part of our test. So we want to resolve. We want to say, okay, I'm going to pass in a wire, and I want you to grab the value of that wire. So let's say if is set this symbols. Let's say if not is set. So if it's not set, then we're going to bail out. This is going to be an error. Actually, let's write a test for that. Okay. Public function, it will throw an exception, maybe? I don't think we've done that in this video yet. For invalid symbol. Okay. And we'll do this should throw, and we'll say invalid. Let's say it'll throw an invalid argument exception. So new invalid argument exception, invalid symbol should throw that exception during, and the call is going to be to resolve, and the argument is going to be a, or whatever. It doesn't matter. We haven't put anything in here, so all symbols are invalid. So let's make that work. All right. So in this case, we got a broken one. It says argument 2 must be of type array. Okay, so it's expecting these to be an array of arguments passed in, so we'll just wrap that in an array. We'll run it again, and now we get a failure instead of broken. So it will throw an exception. We expected an exception. We didn't get an exception. So on the resolve, we'll say if not is set this symbols wire. So if we don't know anything about that wire, then we're going to throw new invalid argument exception right there, that one, of what was it, invalid wire? Invalid symbol. Invalid symbol. Symbol. Right? So let's run that. Alright, so we got that to work. Now we know that invalid symbols, we're going to just deal with them by throwing an exception. And I close my spec. So now we need to make this one work. So back here we've got, if we've passed this point, then we know we have that wire is in there somewhere. So in that case, we'll just say return this symbols wire. right? And that should make it happy, almost, right? So in this case, it says we expected the integer 123, but we got the string 123. So we can go about this a couple of ways. We can say, well, we'll change our test to be less fussy, right? So if we do should be like, then it's all like, whoa, it's fine. Or we can change our circuit to be more strict on these literal values. I'm okay with should be like for right now, so I think I'll leave that there. All right, so now we've got one bit of functionality that works, and the next bit is I want it to work where, let's say we have a literal value that goes into a wire, and then that wire goes into another wire, and then we resolve that, right? So we want to make sure that that works. So we'll do it can resolve, let's say wire pass-throughs or something. So in this case, we're going to do this add group, and we'll do again 123 to A, and we'll do this add group B A to B, right? So we're just connecting these straight across. We pass into 123 to A, then A goes into B, and then we want to see that B comes out as 123. So do should be like 123. And of course that doesn't work because we haven't built that yet. So we'll go in here and we'll say, all right, if so we need to say, all right, if we've gotten to the point where the symbol is a literal, then we want to return that. Let's see, we've got part 0, parts 1. All right, so if is numeric this symbol's wire, then we'll return symbol's wire. So now, and I'm going to put something else in here just for a placeholder. So we're going to say return operation not supported, right? Because we're going to have more operations come in here. So we've got our return symbol wire, and we're going to cast that as an int. And we got, hey, we don't have that operation supported. That's cool. But what I can do now that I've got it cast is I can get rid of this like. And we'll say every time we've got an actual value, we should get that. So that didn't break anything. It didn't help us fix anything. So now we need to find another symbol, right? So let's go back to our resolve. And so we've got if is numeric, right? If, let's see, how do we want to do this? If we have, let's see, if we match just a symbol, right? So from the start, and this is again, here we go, regular expressions, right? So if preg match, we'll do our pattern, and we'll do our, let's say our equation. What do we want to call it? I don't know. Let's say formula. I don't know. We'll say formula for now, unless I come up with something better. So formula is equal to this symbol's wire. And actually, let's do this as a slightly different way. So I'm going to go back up here, highlight this part, this symbol's wire, and then we're going to extract that as a variable, and we'll say it is formula, and replace all 3 occurrences, and go. And so now, everywhere this symbol's wire comes out as this. Oh, we can't quite do it there, can we? All right, let's do it this way. Put it right down here. We'll put this back in place so we don't end up with a notice. And copy, paste. So this symbol's wire, we'll check the is set. If it is there, then we'll use formula from this point forward. So formula is going to be, how do we resolve that? So our check against formula, and then we'll do matches so we can get back what it was. We'll tell it what to do, and then we're going to say if this between the start and the end of the string is one or more lowercase numbers, and there's nothing else in there, and so that's why we've got the start and the end there. Then we're going to say that it resolves to a normal wire, right? So pass through wire. And our matches, we'll put a match on there. We'll say a match goes there. So we've now wrapped that in some parens and said whatever that is, we want to keep it. So we're going to do value equals this resolve, and so now we're getting into recursion. So we're going to call this function again from within itself, but we're going to call it on matches 1, so our capture group. And once we've found it, then we can replace the right-hand side of our symbol table with the value, right? So we can say this symbols of wire equals value, right? So next time, if we ask it again, instead of coming through this part, it'll come through here because we've already done the work. We already know that that pass-through is equal to whatever we want it to be. So we've still got nothing. All right. This resolve matches 1. What am I doing wrong here? Value equals this resolve matches 1. And our formula. Formula is the symbols for the wire. Well, let's take a look. So let's do some debugging here. So I've got my debugger ready to go. We'll turn it on. I think I've got it ready to go. Hopefully I do. Yep, there we go. There we go. So we've got this wire A. This is our first one, so I don't care about this one. Let's go to the second one. So our second one, we have wire A. Why is it wire A again? It shouldn't be wire A again. All right, there's our one we want. All right, so now wire B, and you can see here's our circuit table, right? So we've got A is a 123 and B is A. Right? So let's step through. We get our formula. So our formula is A, and it's not numeric, so it skips over that part. And now we want to match this, right? And we get in there, which is good. And our matches, let's see if our matches are correct. Our matches, we got A, that's good. And now we're going to jump back into A, or to ask what A is. And we have our formula. And our formula is A is equal to 123, which should be is numeric, which we then put in as an integer. And now it returns back that as value. Oh, I forgot my return. That was how simple it was. Durr. All right, so let's put in return int value. How silly. All right, let's let it run. We'll shut off the debugger. And we'll go back to showing phpspec. Let's run it. And there we go, green. Everything's happy. So now we have our first operation done, right? We have, it will handle a pass-through wire. I'm going to put this back outside of there so we know which section it is. Our next bit of code is we need to do, we have a bunch of different things, right? We've got nots, we've got ands, ors, left shifts, right shifts. So we should probably do not next because there's a trick coming up that we need to be able to deal with. So let's do not. So circuit spec, we've got a public function. It can resolve not connections. All right, and let's go back over to our code here. So in this case, we've got not x. So we're going to wire up this part of it. We're going to say 123 goes to x, and not x goes to h, and then h should be this, right? And this is one part where it gets tricky. So we're going to want to fix this, or we're going to want to make sure this works. Otherwise, we're going to have a really bad time. So we'll do this: add group. And we'll copy that 123 goes to x. and this add group, and we'll paste not x goes to h, and this resolve h should be, and h should be 65412. Alright, so when we run it now, instead of getting our 65412, we got operation not supported. And that makes sense because we're not asking for anything in particular from, we're not doing not, right? So let's go in here and we'll say, all right, now we need to check for not. So we'll do if preg match, get our spots saved up, formula matches, all right, and it'll be not followed by anything else, right? So symbols or numbers, we'll say, maybe. Yeah, it sounds reasonable, I guess. Let's see, do we have any numbers in there? Do we even need to worry about that? So let's find out. So we'll do not followed by digits. We don't have that, so we don't have to worry about any digits. We only have to worry about not followed by a wire. Right, that makes things a little bit simpler for us. So not followed by A through Z one or more times. And we want to say, we want to get our wire, right? So wire equals matches 1. That's the thing we're going to look up, except I don't want to call that wire, that's already my parameter. So we'll do symbol. Alright, I need to figure out how to shut those off. I don't know how to do that right now. But alright, so symbol equals matches 1, and we need to resolve that symbol. So we're going to get symbol value equals this resolve wire, or symbol rather. So now we've got a value for it, and we need to not that. So we'll do symbol value equals not, which is tilde, symbol value, and we'll store it. This symbols wire equals symbol value. Return int symbol value. Alright, let's run it and see how it works. It does not work. So, and this is why. So PHP by default, or by every fault, whatever, it doesn't support so-called unsigned integers, right? According to the problem, our values are going to be between 0 and 65,535, but when we not something, when we bitwise shift, or when we bitwise invert it, we end up with a negative number, right? So negative 1, we took 123 and we knotted it and we got negative 124 based on 2's complement and all of that stuff. Man, that is really, really annoying. I'm going to pause and see if I can figure out how to shut that off. Alright, I think that hopefully takes care of it. Alright, we have, so we've got bitwise, we're bitwise knotting something. I'm going to jump off really quick into something that I think is pretty interesting, and hopefully you will too. If not, feel free to fast forward or whatever. So let's do a new snippet, scratch file. Do a new scratch file. So what bitwise not is, I just want text, plain text. Bitwise not says we've got a value, right? So we've got the value, let's say 123, and that in Boolean is represented by some value, right? So let's see what it is. We'll do php-a, and we'll do echo, I think it's des2 bin 123. Nope. Let's see. How can I do this one? Well, I'm going to use calculator. This is an easy way to do it. So if you go to your calculator, it's not helping me much. Alright, pausing again. Be back in a sec. Alright, so on Mac you've got calculator, and you can put that calculator in a couple of different modes. If you go to programmer mode, that one's pretty useful. And we can type in a number, and then down here you can see what the binary for that number is. And so for our 16-bit number means that we've got all of these values here, right? So 4 zeros, 4 zeros, 0, 1, 1, 1, 1, 0, 1, 1, right? So let's write that down. So we've got 4 zeros, 4 zeros, 0, 1, 1, 1, and then we had 1, 0, 1, 1, right? So 1, 0, 1, 1, and I've got too many there. Okay, so when we do not that, so not 123, then we change every 0 to a 1, and every 1 to a 0. That's all we're doing, right? So it looks like this. Now when we do that with a large number, or we do it with a signed integer, we end up with a negative value, right? So this value with, imagine there's a bunch of zeros going off to the left here, that value becomes a whole lot of ones followed by this part. This is the significant portion, or actually in this case this is our significant portion. But we don't have negative numbers in this, right? We only have positive numbers. So we want to make sure that when we do a negative value on this, so we do negative 123 or negative 124 rather, that we get just these 16 bits right here, right? So if we do negative 123, if I can even do that in here, maybe I can't. 123. All right, so we got 2's complement, right? So we're getting this massive big number here, but not quite, right? Because it's saying here it's a signed value. In PHP though, it's saying this first bit, this 1 here, indicates that it's negative, and then it goes all the way down through here, and we get this negative 124. But we really want to chop it so that we only get these values. And the way we can do that is we can AND it with a value where we've got 1s in all of these spots. So anywhere that's a 1 is going to stay a 1. Anywhere that's a 0 is going to turn to a 0. And we're going to have zeros for all of these are going to be implied. So we'll do and we'll do F, 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 right? So that put ands, and it put 1s in all these spots, and it left 0s in everything else, right? So when we run that, we get nothing, because I don't know how to use this calculator quite right. But what we want to do is we want to put that into our code, right? So we want to mask off everything, essentially. I think I'll probably do another video sometime that's just about bitwise operations and all of that. So we'll do symbol value, and we'll do and 0x FF, right? And let's run that. Let's exit out of there, run, and we get the correct value, right? So we've put the right thing in place, except for we're storing the wrong value. So the test is passing because we returned the right value. But if we were to tell it, hey, give us the wire that has this not in it now, we'd be storing the wrong thing. So what I want to do is I want to make a new function called store value, and it's going to take care of doing this integer and ending with 0x FF, or hex FF, right? So we'll do this store value wire symbol value, and we'll do return this wire, not wire, this symbols wire, right? So once we've called this properly, store value, and once it exists, let's make it exist, then we should be all good to go. Right? So we'll do if symbol value is less than 0, symbol value equals, we'll do and equals 0x 7, or not 7, ff, right? And then this symbols wire equals symbol value. Let's see if we're still working. Not yet. Call to undefined method symbols, because that's not a function, that's an array lookup. Alright, there we go, we're working again. And now instead of storing it here, we'll call store. So we'll say this symbols, or no, this store value wire value. Return this symbols value. Okay, and I broke one, right? So I've got this undefined offset 123 for it can resolve wire pass-throughs. And what did I do? So the wire pass-through is one where we have 123 goes to A goes to B. We want to find out B. So we look at B. We say B is not numeric. It has this value, and we need to resolve it. So we got a resolve matches that, which would be A. So we look up A, and A should be our symbol, right? Now let's run through it and see what happens. So I'll turn on the debugger again. Alright, so we're resolving A. We have no symbols so far, so this is not the one I want. Now we have A is equal to 123. This is not the one I want. Now we have A is getting, B is getting value from A, and A is 123. So the formula is A, and it's not numeric. So now we resolve the symbol. Oh, we go back into it, sorry. So now we're going to resolve A. And A comes in and says A is numeric, so we return the integer for 123. Now we've jumped back out of the recursion, back into the formula here, so we're storing that value. We say if the symbol value is less than 0, which it shouldn't be, then we're going to store that value, right? Let's go ahead and throw an int on there. But we've got symbol value for B is equal to 123. Now we're back at a store value, and our symbols has 123. So it should return B as 123, but it says no. Undefined offset in circuit line 38. Alright, line 38 says we're returning symbols 123. Oh, wrong value, right? Instead of symbols 123, I want symbols wire. There we go. Debugger to the rescue. Alright, let's finish running this thing. We'll shut off the debugger. Go run it again, make sure our tests all pass. Hooray, they're all good. Alright, so now we've got, presumably we've got not working, and we've got straight through wires, and we've got literals working. So we need to add some more spec. So our next input is, let's do an OR. So we want a bitwise OR value, right? So bitwise OR value, we've got either, I think in this one we've got either wires connected, or I think they do, in a few places they do wires with numbers, right? So it could be just kg or 7 or something like that. So we need to be able to deal with both of those. So let's do that. We'll do it can resolve OR commands. So we'll do, let's go back to our example here. And let's shut off the calculator. All right, wow, go crazy. All right, so we've got our X or Y goes to E. So we're going to set up the circuit with these bits here. So we've got those two. We'll just paste those in there for right now. And we've got OR. And we've got E is 507. Okay. So let's paste that in there as well. Comment this all out. Alright, so add group 123 goes to X. Add group 456 goes to Y. And add group X or Y goes to E. Alright, and then we want to resolve E. So resolve E should be 507. Okay. And we'll come back in a bit and we'll add other ways to do the same thing. So maybe we'll just literally put 123 or Y or something like that. Make sure that it works with both. So we run it, it fails, we don't have the operation for OR. Now we need to get the operation for OR. So we'll go back to our circuit. Do if preg match do our bit there, formula matches. Alright, and we want to do a matching group followed by OR followed by some matching group, and we'll do either digits or letters. And we'll do the same over here, either digits, one or more, or one or more letters. So either one, right? So we'll do value 1 equals matches 1. Value 2 equals matches 2. Now we need to determine if we need to do anything more with these, right? If they're both just if they're both numbers, then we probably don't need to do anything. If they're both symbols, then we need to look them both up. So let's do this. Let's say let's have this function do it instead of just do it in OR. I think it might work best if we do that. So we'll do value 1 equals this resolve value 1. Value 2 equals this resolve value 2. And then we want to get the result, and the result is going to be value 1 and then a bitwise OR, so a single pipe value 2. We're going to store that, so we'll do this store value for wire, and the value we will store is result. And then we will return result, or symbols wire, whichever went, right? Let's do symbols wire. Alright, let's run it, and it works, which is good. It means I didn't mess up yet. But let's add a few more things to make sure that it can handle the literals, right? So it can resolve OR with two literals. So I'll do this, add group, we'll do 123 or 456 goes to X, and this resolve X should be 507, and I think this will break. Yeah, it does. So we got we're asking for a wire called 507, and this is where I want the circuit to do it, right? So if we end up resolving a wire, which isn't really a wire, but we're going to treat wires and symbols the same, then we're going to get, let's see, operation not supported. Expected 507. That is interesting. Why did I do that? Should be 507. Alright, so if is int wire return wire. Alright, and we'll run it. Alright, still operation not supported. Let's see what happens. So I'm going to do, again, some more debugging, but I'm going to change it a little bit. We're going to go and add a condition. First I'm going to add a breakpoint here for this one that's failing. So we'll say here's a breakpoint, but I don't want to stop there. So we're going to open up more. Let's say do not suspend. And then back over in this one, we have this breakpoint on line 28. I want to suspend only after the one that we just shut off was, so line 58 in circuit spec. So once we've hit this one, then I want to break, right? So I don't care about all the rest of them, they're fine, but I want to stop after we've gotten to the right test. Alright, so now we're looking for wire X. Our symbol table table's full of garbage. I wrote the symbol table wrong. That's what my problem is. Alright, let's go back to circuit spec. This is not a pipe, this is an OR. Let's run it again and let it go. Let's see what it says. Alright, it can resolve with 2. We got an exception. Invalid symbol has been thrown. Alright. Let's say is numeric. And we'll return an int wire. Shut off the debugger. Alright, and it worked. And if we run it again, that's working. So now if we ask for a wire from a literal, it says that it's the value of that literal value, except for we cast it to an integer. Alright, so we've got OR working right there, and our next bit we need is an AND. So something like this. So let's go back to our example, and we'll copy that out. Actually, let's do just a couple more tests. I don't think that any of these are going to fail, but it doesn't really hurt. So we'll do it can resolve OR with literal and symbol. So we'll say this add group, and we'll do 123 goes to X. We need some spaces there because otherwise it won't work. Add group, and we'll say X or 456 goes to Y. This resolve y should be 507. And that's still working. And we could do the opposite way too. Can solve OR with symbol and literal. We'll do this add group 456 goes to y. This add group. And on this one we've got 456 goes to y, and we've got 123 or y goes to e. This resolve e should be 507. Thinking this should work. It does. Alright, so we kind of covered everything we needed to cover by throwing in this this literal bit here of if it's a number, then we're going to just return the value. But now we need to do AND, so let's write some tests for that. So it can resolve AND instruction. So this add group, let's go get our example. So we've got an AND with x and y goes to d. And we've got this add group, and x was 123. And we've got this add group 456 goes to y, and this resolve d should be 72. Alright, when we run it right now, we should get something like invalid or operation not supported, and we need to add in some stuff for our circuit to match an AND. So do if prig match formula matches. Okay, and our example will look very similar to this. Just copy that out. The only difference being is that now we've got an AND here. And this is going to look very, very similar, so we'll copy that out. And we'll paste in AND, right? So now we'll do an ampersand. Single ampersand means bitwise. And that works. So now we're handling AND. And I can go through and write more tests, or you can go through and write more tests to make sure that it works with literals, but I have no reason to believe that it wouldn't, because resolve is now being used to deal with literals, and we know that that works, and that's passing in right there. Alright, so our next circuit input that we need to deal with is right shift. And so this is taking a Boolean and shifting the values in the Boolean to the right by some value. By some number of times, right? So if you do Rshift 1, then it means move every bit to the right 1. If we do Lshift, then it means move every bit to the left, however many this says, right? So let's get our example. We'll say X shift or X Lshift 2, and we'll go back to our spec. It can resolve Lshift instruction. This add group, and we need to add in our X, so we'll do this add group quit it. Alright, X gets 123, and this resolve F should be 492. Alright, we'll run it. We should get an operation not supported. That's fine. We'll go back into our circuit. I'm going to copy this entire thing because it's going to be very, very similar. And we'll do, what are we testing, Lshift or Rshift? Lshift. So Lshift. And Lshift, we have that. That's our symbol in PHP. So it's going to shift to the left by this many values. Shift the value in 1 to the left by the number of things in value 2. Cannot. We asked for something we don't have. Let's see what we asked for. What did we ask for? We asked for A. Why did we ask for A? Probably because I wasn't paying enough attention. Alright, circuit spec. Alright, so I broke that test. Invalid symbol A. There we go. Invalid symbol X. Why do we have invalid symbol X? Because it's not X, it's Y. Or no, it's not. X. Should not matter what order we do this in. See if it does. If it does, then I've got a problem that I need to fix. So invalid symbol X. Oh, I did it backwards. 123 goes into X, not X goes into 123. That makes no sense. Alright, there we go. So we've got Lshift done. We need to do Rshift. So can resolve Rshift instruction. This add group. And let's get our example. So we're going to do an Rshift by 2 and put that into G. And we have 456 goes into Y. This resolve G should be 114. 114. Nope, I have a typo. Alright, so now we've got 114, but instead we got operation not supported. Let's go in, let's copy paste some fun stuff here. We'll change this to Rshift, and we'll change these two symbols to greater than, greater than. We'll run that again, and now we get seemingly working stuff. So we could do this entire circuit and test all of these values. Let's go ahead and do that. Make sure that everything is working as expected there. So, nope, I don't want that. I want it in our spec. So it can resolve full sample circuit. Alright, I'll paste this in. Let's see. Seems like there should be a way that I can do this with less typing. Let's do this. This. Alright, mostly with less typing, sort of. Maybe not. Let's fix all these guys. And let's fix these guys. Oh my word. Thought that would save time. Maybe it does overall. I don't know. It's a little bit frustrating. Alright, now we need our answer table. Let's get our answers. And paste those in there. Comment. Alright. This resolve D should be 72. This resolve E should be 507. Oh man, I'm having typing problems. This resolve F should be 492. This resolve G should be 114. This resolve H should be 65412. This resolve I should be 65079. This resolve X should be 123. This resolve Y should be 456. Alright, let's see how we did. Everything's working. Alright, that's good. So now what we need to do is we need to get our input in for all of these, and then we need to tell it to resolve B, or not B, should resolve A, which should give us back, it should, there's our A, look at that. It should jump back all the way through, find the values that it needs to, ignore the ones that it doesn't need, and we should have our answer. So let's do, we need to describe a new runner, puzzle 1. Alright, and let's go, oh, I gotta run it. Create it, run it, everything's good. Alright, we're going to use a new circuit. So circuit is a new circuit. And we're going to loop over some input, so we need to get the input. So we'll do input equals file, dir, input, day 7, input.text. So there's our input. It's now in an array. We'll loop over input as connection, circuit, add group connection. And now we need to determine what the value of A is. So we'll say the value of A is circuit resolve A. So day 7, puzzle 1. Let's take a look. So 3176. If we've done it all correctly, then the value I should be getting for mine is 3176. Let's run it. And we got it. And I forgot to put in some new lines, but this one was nice and quick, no waiting. 3176, so that one works. I'm going to go ahead and end the video here because I'm sure it's super long, and record a second video for part 2 that I will put up right after this. I'll be recording it here in a few minutes. Thank you for joining. Thank you for sticking around. I hope this was useful. If you think a video about bitwise math and Boolean and all of that would be good, please let me know in the comments. Remember to like, subscribe, tell your friends, all that fun stuff. And again, thanks for joining. See you in a bit.